with examples. So that'll be done. The plan is to have a test next Friday. So next Tuesday and Wednesday will be like non-math working days. On Tuesday, I will be in my room, but only sophomores will come on Tuesday to class. Juniors go somewhere else, and seniors go somewhere else.
What are we going to do?
Yeah. We won't do anything. And then Wednesday, I'm testing, and so you won't have class on Wednesday. So next week we won't do anything Tuesday and Wednesday, but we will have a test on Friday over this stuff.
What about Monday? Is Monday just normal?
Yeah, Monday's a normal day. Well, Tuesday is the EOC, the STAR, the Algebra 1 STAR, and for freshmen. And so they have sophomores going to their regular classes that day, but juniors and seniors go, I thought, to the arena.
Yeah, I thought we were having an assembly.
They are.
I think.
They are. Miss
It was like the Hawks are having
Okay.
And Miss
Yeah.
I got 2 questions.
Hang on. Let's do this. Can you save your questions for later?
One of them involves that.
Okay. What?
Once you get done, can I copy it?
Yes. Okay, so we're ready for the pyramid. So our pyramid formula is 1/3 capital BH. So I'm going to go ahead and recopy that over here. 1/3 capital BH. So this is our formula for all pyramids. And capital B stands for area of the base. So let's look. Do you know what the area of this base is?
8.
4. It's a square pyramid, so that means that each side of the square is 2, and you find area of a square by taking length times width, and 2 times 2. Perimeter, yes. Area is 4. So I've got 1/3 times 4 times the height. Do we actually have the height to this?
No.
We do not. So I need to draw it in. The height always goes from that top vertex to the middle of the base. It forms a 90-degree angle there, and then I'm going to make that triangle out of it. So this is what I need to figure out. That's the actual height of the pyramid. Do you know what this length is right here? That's a 1. Okay, so what would Pythagorean theorem look like here?
1 squared plus x squared equals 4 squared.
Good. So 1 squared plus x squared, or x squared plus 1 squared, equals 4 squared. 4 is the c. It's the hypotenuse. Okay, I want to know what that is to the nearest tenth. Okay, 3.9. So 3.9 is the actual height of our pyramid. So 3.9 will go into our h. Okay, and work that out and tell me what you get.
4 squared.
So to the nearest tenth, what do you get if you work that out?
5.2.
Good, 5.2. I'm going to keep it meters, and because it's volume, it would be meters cubed. Now, as far as the multiplying by a 1/3 is concerned, you can multiply by a 1/3, or you could divide by 3. No. You either multiply by a third, or you divide by 3. Either way would give you the same answer. Like multiplying by a half is the same thing as dividing by 2. Multiplying by a third is the same thing as dividing by 3. So you can either multiply by the third, or you could multiply those and then divide by 3. Either way. Okay, our next one is a cone, and our cone formula is the same formula, 1/3 capital B H. And capital B stands for area of the base. So how do we find area of a circle?
Pi r squared.
Pi r squared. So that's why you see here that the capital B got replaced with the pi r squared. So that's why you see that. So it's 1/3 pi r squared. And let's look back. And what is the radius? 10. 20 is the diameter. It's all the way across, so 10 would be the radius. And then I need to know my height. And what is the height of the cone? Do we know?
7.
The height is 7. It goes straight up and down. It hits in the middle of the cone, so the height is 7. Okay, Keeping that in terms of pi, tell me what you get. Yes, 233.3 pi, and then meters cubed. Okay, and then the last one is our sphere, and this formula is quite different than all the others. 4/3 pi r cubed. And so you can either multiply by 4/3, or you can multiply by 4 and then divide by 3. So however you want to do it. So let's look at the sphere. Do we know the radius? The radius is 5. So it will be 4/3 pi times 5 cubed. Okay, leave that in terms of pi, and let me know what you get. And if you need to see me put it in the calculator, I can do that.
Are you okay, Miss Wood?
I'm okay. I just hate it when I drop the calculators.
500 divided.
Well, I didn't mean to drop it.
Is it 500 over 3 pi?
Well, I'm going to leave it in terms of pi. So you have choices. You can either put the 4/3 in. So you can either put the 4/3 in and do it like this. Or you could take the 5 cubed, take the 5 cubed times 4, get that answer, and then divide by 3. Either way you get the same answer.
I
So
did that in my head.
about 166.7.
How do you keep put a 3
Oh, this little guy over here that's under the clear, it's above the divide, this little caret symbol,
Oh, and then you just put whatever.
and then whatever number you want. Okay, so our foldable is complete. We've got examples of everything. We've got all our formulas on there. Okay, let's go to page 18 and let's just practice some problems. And I don't plan on doing all of these.
The sheet you took off was the homework, correct?
Uh-huh.
I'm just making sure.
So let's go to page 18, and I'm just going to do a few of these so you guys have time to try to get your work done in class. Okay.
Do I have one of these blank?
Let's go to example 2. Do I have one of what? Yeah, you can have it for right now.
No, I mean
A blank one? Yeah, I'll give you a blank one here in a minute. You can have that one for right now. Okay, let's go to example 2. What is example 2? What shape? This is page 18.
Square pyramid. Oh.
It is a square pyramid. So for all pyramids, I use the 1/3 capital BH. I use that for all pyramids. So, yes. Okay, so when I look at this problem, capital B stands for area of the base. So what is the area of that base? 9. Length times width, 3 times 3 is 9. And then, do we know the height of it? 6 is the slant height. The slant height is the height of a lateral face, but it's not the actual height of the pyramid. The height of the pyramid drops down from that vertex and it hits in the middle of the base, like right there. So it's going to make a 90-degree angle, and I'm going to make this triangle like this. So this is my height that I'm looking for. I'm going to call it X. Do you know what this little piece is? 1.5. So that little piece right there is 1.5. Which of those numbers is the C for Pythagorean theorem? The 6. The 6 is the C. So it would go what squared plus what squared is what squared?
1.5 squared.
Plus x squared equals 6 squared.
Good.
6 squared minus.
Yeah. Okay, take a second and figure what that is to the nearest tenth. You have it? What do you have, Shreya? 5.8. Good. So we get x is about 5.8, and that actually is the height of the pyramid, so I'm going to put 5.8 here. Okay, and then take a second and calculate all of that, and let's see what you get.
Don't yell it out.
You want me to tell you?
Yell it out.
Just give everybody else a chance before you do that.
Yeah, in just a second. Starting to feel hostility in here.
What's up? I know. No, I told everybody.
Okay, Caitlin, what'd you get?
I got 17.4.
That's it, 17.4, and it would be feet cubed. Very nice. Okay. I'm not going to do example 3, but my question is this 6 right here, is it the slant height or the actual height? That is the actual height of the pyramid, but I'm not going to do it. Let's go ahead and go to number 4. So looking at number 4, what shape do we have going on? A hexagonal pyramid or a hexagonal pyramid. The fact that it's a pyramid, we're going to use the same formula that we used on example 2. But capital B, I'm going to find this differently because capital B wants the area of the base. I think I can do it this time because we've done it so many times without me actually redrawing the shape. So do you agree that this right here is the apothem? Yeah. Goes from the center to a middle, and I'm going to make a triangle out of it. Faith, is there any way you could just have a conversation later? Yeah. Thanks. So if this whole piece is a 10, what is this piece right here? A 5. Do you know what the apothem is without me showing any work? 5 square root of 3. Because remember, we know that this is 30, and across from the 30 is x, and we know this is 60, and across from the 60 is x square root of 3. Okay, so when I go to find the area of my hexagon, I know that's 1/2 AP. We just figured out that the apothem is 5 square root of 3. How about the perimeter? 60. 10 plus 10 plus 10 plus 10 plus 10 plus 10. So the perimeter is 60. Okay, so let's keep the square root of 3. What's 60 times 5 divided by 2? Good. 150 square root of 3, and that is the area of the base. So that will go into my capital B. So it's going to be 1/3, 150 square root of 3. And then how tall is that? Do we know? 11. The 11 is the actual height. Okay, just go ahead and put all that in and give me a decimal to the nearest tenth. Don't blurt it out.
Don't blurt it out.
I could draw a stick.
To make it to the square root of 3, or do you just want us to leave that?
Go ahead and put the square root of 3 in the calculator this time.
It'll be a full number.
Well, actually, if you put it in your calculator just like this, you should get a decimal. Like if you, yeah, if you round earlier, then it makes that different.
Did you get that one? Or am I just like
Mackenzie.
Wait, hold on.
It's too soon?
Just hold on.
Okay, hold on.
Okay, yeah, you're good.
Okay, Mackenzie.
I got 952.6 meters.
Yes, 952.6. You didn't get that?
No.
Did you divide by 3?
Yeah, we did.
Or you either multiply by 1/3 or divide by 3. So I don't know. Like in my calculator, when I do it, a lot of times I'll put in the 1/3 in parentheses like that, and then the 150 square root of 3, and then the 11. But I could divide by 3 if I wanted to. Okay, let's go to number 7. Number 7, what shape do we have here? This is a cone, so I'm going to look at my cone formula, and our cone formula is 1/3 capital BH, and capital B stands for area of the base. And what shape is my base? How do you find area of a circle? Okay, so it's going to be 1/3 pi r squared. And what is the radius? 5. Do we know the height of the cone?
Yes.
13 is the slant height, so we need to actually figure out this height right here. So if you do Pythagorean theorem, it would look like what squared plus what squared is what squared?
5 squared plus x squared equals 13 squared.
Okay, take a moment and tell me what that is.
So it's 12. Sorry.
Because we just said.
Wait, is that squared 13? Okay.
13 squared. It does kind of look like a B, doesn't it? Did everybody get 12? Okay, so 12 is the height of the cone, so 12 is going to go into my H. Okay, work that out, but keep it in terms of pi. So working it out and keeping it in terms of pi.
Is that the last one?
I'm going to do one more real quick, because the sphere is super easy. I just want to make sure everybody knows how to work the 4/3. 100 pi. Does anybody need to see me put it in the calculator?
Do you want us to put the square thing outside the parentheses?
Yeah.
That you don't Yeah.
You got it? Okay, number 8 is a what? A sphere. So I'm going to look at my sphere formula, and it is 4/3 pi r cubed. So 4/3 pi r cubed. And do we know the radius?
6.
The radius is 6. So it's 4/3 pi times 6 cubed. Okay, I want it in terms of pi, and then I'm going to draw a stick because I want to make sure everybody knows how to put this in your calculator, and you have a variety of ways that you could do it. I'm going to draw a stick.
How do you do the cube answers?
It's that button above the divide bar. It looks like a roof.
Like,
Yeah, it's called a caret. That's its technical name, but I don't know why. Yeah. Are we ready? No, wrong class. It's like I don't have Jackie in here.
You want to keep it in pi or no?
Yes, keeping it in terms of pi. Haley? Yes, 288 pi. Does anybody need to see me put it in the calculator? There's a couple of reasons why I have you guys keep it in pi. One, I think it's easier if you don't have a calculator. And two, sometimes questions want to keep it in pi and sometimes they want decimals. If you know how to keep it in pi, it's really easy to make it a decimal after that. So, okay, your assignment. It's going to be this next page. And the last time we did the assignment that looked like this one, we didn't do 6 and 9. So let's just go ahead and be consistent and cross off 6 and 9 again. I do want it on a separate piece of paper, and I still want the 3 lines: formula, plug-in of numbers, and answer. But I think you guys can finish before you go. So you have 7 problems left, separate piece of paper, formula, plug-in of numbers, answer.
Are you singing? Like this, Chris.
Okay. I wonder what happened to you.